Cool. Hi, everyone. Hello, welcome back. Hopefully that was a refreshing break and back into the warm, stuffy GH001. So we're going to get started with lightning talks. Also, maybe thumbs up if you can hear me online to make sure the sound's coming through. I gave myself a thumbs up. Can you? Cool. Awesome. That's coming through online. Sweet. Okay, so we're going to start with the lightning talks, which will take us through to lunch. First thing to say is we've got a list of lightning talks for this room here. If you're giving a lightning talk and you can't see your name as I scroll down this list, it means you're in the wrong room and you're supposed to be in the other room. So if you haven't seen it by the end there, now's your chance to go to the other room. Awesome. The system has worked. Cool. So the way this is going to work, to remind everyone, so the themes are broadly the same across both rooms. Don't worry about having FOMO from not being in the other room. They're covering very similar topics. We are going to record this. Are we recording now, Michelle? Do you know? Cool. Recording this so you can see the other one's been recorded as well. Yeah, so you'll be able to see that one as well. There's no superiority between the rooms, Chris. I'm not recording one and not the other. Where's the 001? That's what I'm going to say. So we've asked all the lightning talks to focus on like knowledge sharing, collaboration, how people can get involved. Well, we might have some time for some questions at the end, but the plan is to just whistle through each of the presentations. So it's not so much like I'll have like a really interactive Q&A everyone, as much as, oh, that's really cool work. I'm going to make a note of that person and the ways that we can get involved and chat to them over lunch, in breaks, afterwards, all that kind of stuff. Also, if you're giving a talk, we are timing you. We have our 1 minute left thing here. You have 5 minutes, and the amount of you're sending through like 15, 20 slides, some of you. There's a real difference in interpretation how many slides a 5 minute presentation. We will be cutting you off at 5 minutes. If we end early, we can, like, there's lunch and there is outside as well. We also just have like a casual Q&A in here. You can ask some questions on the Zoom chat as well. So no questions until they're all done, and then potentially we can have a chat if there's some time left. The order on here also might not be the same order that was given to presenters before. I'm sorry if that's changed. That's just the way it is. Cool. So without any further ado, I'll check that this is working. Alex, here you go. And I'll let you know when your time is starting. Yeah,
it's working.
There's just the one of the ones. Brilliant.
Hello, I'm Alexander Roberts. I'm the Research Data Manager and Digital Humanities Team Manager here at Swansea University. And it's a big welcome to everyone here. Thanks very much for coming to the university. I'd like to just share some interesting thoughts perhaps to somebody regarding our most recent work around creating a TRE at Swansea as a central research computing facility and resource. Full disclosure, I'm not working with Simon and Simon doesn't work with us. That's very much separate from what's going on at the centre with regards to research data management and research computing support. So just to let you know. Okay. Oh, then we got another one. So last year, sort of mid-year, we thought, well, things are starting to get really tasty out there. We've got an awful lot of movement with regards to policy development. So we firmed up approximately 18 months ago, actually, firmed up our secure and security-sensitive research policy, as well as due diligence policies in international relations and all sorts of other areas, as well as beefing up our cybersecurity teams at the centre and other investments. So we realised, well, we didn't realise, it's just, I suppose, the powers that be finally got the message that we needed to have something like a trusted research environment, or TRE as we're calling it. And there suddenly became some money to start moving forward. So we identified Amazon as a partner, as a development partner, AWS, and we moved forward with them to a point where we were able to start a prototype project. And that was November last year, and that ran all the way through to March this year, where we had a prototype research project, a real project, but with mothball data, where we were able to build out secure computing storage, all the various layers, all the software security, cloud security, all those other things, and learn it at the same time. And that finished in March, as I say. So let's go. This is doing this. I didn't tell it to do this one. Yeah, I'm going to finally get right. That was it. That was the end. So we've now got on paper and for real a resource where we can look after highly sensitive data. We can manage egress and all the other activities that need to happen on that. We're super wet behind the ears when it comes to TRE. So we're very much here to learn what you guys are doing, and it's great to be part of your community. But we have all those elements in place right now to support projects moving forward. The challenge now, as we move forward, is that we've only actually done one proof of concept project within it. We have set up, the lines of communication. They're quite brittle at the moment between ourselves. We sit in the library as the research data management team and the cybersecurity team, which works at the center in IT services. We have ad hoc meetings, but it's very much scrabbling together as we need to when there's a research funding application that suddenly pops up. We had no prior warning about it. It's the day before submission. If any of this is sounding familiar, then this is normal for us as research computing support. But we always do it on-prem. We've always done it in our virtual cloud infrastructure, VMware, and all the rest of it. But not only do we have this new super secure environment, but it's also cloud hosted, and we have some challenges around that. Those challenges, what are they? Well, it's a small team. It's myself and a senior research computing engineer. What? You may say, how can that work? Well, that's kind of the same thing that we said, but there's a hearts and minds kind of situation here, and we needed to start the process, and if there is demand, then the team will grow. It's that sort of thing. That's the kind of approach that we're working on at the moment. We can run 2 concurrent projects at any one time, and that is our capacity. As I mentioned, the transition from on-prem to the cloud is an ongoing challenge. The challenge is to do it often, work in the cloud often. It's not so much the technology, it's just doing it often enough for it to become routine. Every project requires a bespoke computing resource and setup. So that's normal, but now we're building it in the cloud, which is an added layer of problem solving that we require. The capacity planning, well, actually, we need to know what's coming downstream to us. That reporting and that information isn't there routinely being delivered. So we really need to know about that. The communication between stakeholders needs to be firmed up and to become more formal. It's very ad hoc at the moment. And the messaging and signaling to our researchers, the PIs who want to get on board with this, and the faculties, is something that we're working on at the moment. Thank you very much.
The next slide, whoever is next.
Hi, good morning, everyone. Okay, it works. So good morning, everyone. So my name is Ifeanyi Chukwu. I'm from Leeds, University of Leeds in West Yorkshire, and Chris is my colleague there. And we're a team of 4 managing our platform, which is called Laser, which I think is quite a cool name. So because it's like Leeds Analytics Secure Research Environment, and it's been running for a number of years now, until the last 2 to 3 years, where it was moved to the cloud. So Blazor, really, we've had about 470 projects. Different projects have come and gone, and at every point in time, we have up to multiple dozens of projects going on at every point in time. So it's also NHS DSDP certified and ISO 27001 certified, which really gives confidence to our data providers, retailers from NHS and etc., to provide data to researchers that are using this platform. So, and just very key information, I don't know if I've mentioned it, is based on cloud, on Microsoft Azure platform. And also, there's no internet access within that environment, and you cannot download anything from Laser to your local machine. So, and it's tightly controlled by my team that Chris is part of. And so one question that you may ask is, since there's no internet access, how do researchers use their platform, use the software, general software that is being used for research, like Python, R, and all those things? And also, just to draw attention to here, I written here TRE, VRE. I forgot to change it to TRE because we're also grappling with the name, VRE and TRE, because we're also in that stage. So VRE, we used to call it virtual research environment, but we are now wanting to call it TRE, trusted research environment. So we use a package, a system called Artifactory to enable researchers to have access to Python packages, R packages to do their work. So this talk really is more of how we manage this platform and what we do on our day-to-day activities managing this platform. So as a team, we help to import data. We help the researchers to import their data into the platform, and we use a secure data transfer, which we call locally BISCOM. And this is encrypted in transit, so that when data providers want to give us data, we give them access to our data transfer platform, and then they send the file securely into the VRE. And then as a team, we review the data transfer process to make sure that the data is really what it says it is. And if researchers also are done with their work and they want to export the data from the VRE, from the TRE, we also review to make sure that they are not exporting sensitive data, that the data they're exporting is maybe research outputs, plots and charts, etc. And we coordinate that process for them. And we've also, because we have this growing number of projects that we've been supporting and working through, we've historically generated a large number of data to start building some platform to enable us and the researchers to manage and better understand the platform. So we've collected this data to build Laser dashboard on cloud, on Power BI. And what has happened is that this really helps in our funding model, really, because each project that is coming on to use Laser, we enroll them in a process called Research Management Process, RMP. So, and then they also need to include, at the early stage of their research proposal is when they come to us that they have sensitive data, they want to do their work. And then we enroll them in that RMP and provide them some costing estimate, bespoke costing estimate, depending on their computational need. So this costing estimate, they include that in their grant application so that it's funded by the researchers themselves. So we've provided this dashboard to enable researchers to monitor their costs. Are they overusing their budget? Are they underusing their budget? And also monitor other activities within the VRE. So I hope you're able to get one thing or another from this talk I've given today. And for any reason, if you want to reach out to us and ask any question, my email address is there, and the email address of my team is there as well. Thank you very much.
Oh, I can probably publish.
Yeah. So hello everyone, I'm Arlene Casey. I work at DataLoch TRE, which is at the University of Edinburgh. So I'm going to talk about SARA, which is one of the UK driver projects. And it's a collaboration between several of the Scottish safe havens. So that's Grampian, Glasgow, obviously Edinburgh DataLoch, and the Public Health Scotland, which is the national safe haven, and then some of the universities that you can see along the bottom. So SARA is about semi-automated risk assessment at the data release stage. And we focus particularly on clinical free text and data provenance. So in clinical free text, so unstructured health records, they say about 70% of health data is unstructured, but we don't release anywhere near that amount because of the privacy risks that exist in it and the time it takes to kind of deal with those privacy risks. So this part of the project, well, I should say, first of all, we focus on two different ways of defining those risks. One we call direct identifiers, which is pretty well publicized in the literature and thought about as names and dates and addresses, etc. But we also think of risk in terms of indirect identifiers. So these are things that exist in the text about somebody could have had a rare accident, could have something about their social condition that could release a patient's identification. And so this project, we're focusing on indirect identifiers, and we're doing a case study on discharge summaries applying NLP techniques to try and understand and map what are indirect identifiers. We're also creating a dashboard, so a privacy risk dashboard that draws together the indirect and direct risks to be able to share with data analysts and information governance so that they can get a sort of visual way and a much more interactive way to understand what are the risks in the data, which we hope will lead to a smoother process for releasing the data and more confidence, excuse me, understanding about what's in the data. On the data provenance side, we're looking at semi-automation from the data request to the data release stage. And the idea is to build a sort of easy access portal that's online with audit trail. And so there's been a lot of work in talking to researchers, TRE analysts, information governance across the safe havens to try and understand what are the issues and what would people like and how will it work. A lot of work has gone into designing the online portal in terms of the design of the front end, how would that work? And of course, obviously the back end as well, where you're trying to collect that kind of information. And Milan from Aberdeen, who's been working on that, he's developing on the ship ontology that Aberdeen's done previously, but he's also been collaborating or looking at what the TRE FX project is doing to make sure that he's not developing something that's not compatible, because we want to collaborate and work together. So embedded throughout all of this has been public and patient involvement. We've partnered with Ipsos Scotland. We've had a number of workshops and a survey. So the workshops have been from sort of bringing the public up to date or up to speed with what is a TRE and what are privacy risks. And then there's been a lot of workshop kind of sharing of things like discharge summaries and the designs of the online portal to get that kind of feedback. And we've embedded that sort of learning in informing about the dashboard development. So our final report is pending. So we've seen sight of it and it looks really good. And so these are just some highlights of the what's in it. So broad support for use of social and healthcare data. The public are really keen that we have transport and accountability. And particularly in semi-automation, we had a lot of questions about semi-automation. How do the public feel about that? They want to know that there is some human oversight in that. And so there's broad conditional support for that. And we had a lot of talk about different privacy risks in the free text and how we would account for those. So hopefully we'll be publishing that soon. And then finally, just want to say about the futures and the benefits of the TRE collaboration. So we've had a lot of interest in the dashboards. There's a lot of value seen in them. So we are, if anybody's interested, get in touch about collaborating for the future with those. And we'd like to take them a bit further. I'm also working on semi-automation of tools for free text privacy risk. Obviously, this is a use case for discharge summaries. We could apply it elsewhere to other types of data. And I think Emily said earlier about oiling the kind of collaboration. I have to say that their funding has allowed us to do that and work together broader.
Oh, right. The colors have all changed. Oh, no. Okay. Right. Okay. Gotcha. Okay. Good. Yeah. Hi, everyone. I'm Chris Cole. I'm a senior lecturer at the University of Dundee, also research lead at the Health Informatics Centre, also in Dundee, one of the regional safe havens in Scotland. So I'm representing both researchers and TRE providers, and we've been providing a TRE for over 10 years. I'm also PI of this DARE project, so I'm in the middle of the 3 DARE projects that are being talked about in this session. And I was also PI on the open source TRE project Treehouse that we led on last year. So that's me. So the landscape, I don't really need to tell you all that TREs are essentially the future, especially with all the data leaks that are happening at the moment around left, right, and center. I think people are more aware about data security and making sure that data is managed safely. The issue is, and as we'll see today, there are lots of different implementations of TREs. People have a slightly different definition, and they have things done in a slightly different way, whether it's cloud, on-prem, community, commercial, and there's a variety of different accreditations available to you. As part of SATRE, so we are working openly and transparently with the community. So the SATRE project actually kind of embryonic was at last year's UK TRE session in Newcastle. And so throughout we've been open, and so you can see us on GitHub and follow us on Medium and places like that. And you'll recognize this icon from Hurry. So stakeholder activity, we had a survey of 100 people, and we're running fortnightly collaboration cafes online. Please come along. Next one's next week. And as I say, stakeholders from right across the board, from the public up to governance and strategy and policymakers have been involved in designing the specification that we're designing in this project. And so the strategy we took was threefold. So the first stage was to engage with people and learn and explore and bring everyone together and bring the information in a common standard, and then trying to reflect that and simplify it and specify the specification. So we're currently at version 0.3, shortly going to have version 1. And so now we're at the guide and sustain phase of the project. So to try and define how we develop the governance model for maintaining the specification long-term, and to get proper sustainability for the specification, so it doesn't just die, and it won't just die, given the level of engagement we've had. The specification itself is very structured, and it has 75 mandatory statements, which we define as what's considered to be a minimum TRE. So please get involved and compare against with your TRE. As I say, we've taken an architecture approach. This is not my specialty, so the team, so Tim up there in UCL is architected this very carefully, so we can build tools on top of the specification. And we've worked closely with the public and done some participation, generated some outputs and some infographics, and we're going to do a video shortly. And the summary from those summary workshops has been security, anonymization, safety, those sorts of concerns that people have. And I really want to stress the importance of the sustainability. The specification will continue to be maintained, so it won't end with the DARE project, and we're going to work very hard to do that. And there's growing interest by accreditation bodies, because we sit quite nicely in between, accreditation at the top, and then, how do you actually do the stuff at the bottom? And we allow in the middle to kind of be the bridge between that. And so we're looking at how to build in the future, build in a governance model with a structure, with a board or a steering committee or things like that. So I've suggested a breakout community session this afternoon, so please come along and vote for it or join in or whatever if you're interested in this and want to contribute. So QR code to see the specification. Perfect. So please, if you have a TRE, you can evaluate yourself against it. We evaluated 1.5 of our TREs. The HIC one is on its way. The Turing one has already been evaluated and passed, thankfully. So, so please comment on the specification as well. It's not fixed in stone. And join the collaboration cafes. So thank you for listening. And we have a talk tomorrow that where did Jim go? Jim's going to give a talk tomorrow at the RSECon on this as well. So thanks, everyone. Next slide. So yeah, Simon.
Okay, thank you. So I'm Professor Simon Thompson from Swansea University, and we're going to talk about the DARE project that we were funded to do. But just some background, we do run trusted research environments. We're running 28 trusted research environments, and each of these are quite large in scale. So SAIL, for instance, has got currently 260 active projects with 500 plus users, and they scale all the way down. And to make it more confusing, to make the definition of a TRE even more impossible to say, we've started doing TREs inside TREs. We've got 5 of those now. And we've got virtual TREs inside TREs. So I think this is an exciting landscape, and there's plenty of opportunity for development. We also run trusted research environments similar to the ones in the UK. So the 28 that we just talked about are the ones in the UK, but we also run a lot in Australia and a big one on Azure in Canada. But here to talk about the DARE project. So it's a proof of concept project, and it's to link the national TREs of one of the national TREs of Scotland and Wales together. They both have TREs. They all do the same thing, but they look very different, and they operate similar but differently. What we're doing is we're putting plumbing in between the TREs to allow the TREs to communicate securely and safely together while still conforming to their governance model. And we're doing this by establishing on a per project basis a pop-up TRE that is in a known state that through the pipes in the ground as a metaphor can speak to the other TREs and access the data in real time from more than one TRE. The way that we're doing this is we're socializing the national TREs, the idea that a pop-up TRE is not dangerous, and that actually we can have a consistent, we can have the existing governance models apply, and you don't have to change anything at all. But obviously this pop-up TRE has to be extremely consistent in capability and governance and user experience, has to be certified, it has to be exactly like everyone thinks it's going to be. The way that we're doing this is we're expecting differences between, so we got Wales on the left and Scotland on the right. The red area is the pop-up TRE. The things around it are what the local TREs have decided looks normal. And that's absolutely fine. So we're placing it inside a TRE and surrounding it with however TRE decides to run itself. We are, however, building this very much software-based. Everything is software-defined. Everything is very different between the TREs. So, for instance, we run ourselves on Kubernetes and VMware, whereas the Edinburgh run themselves on OpenStack and KVM. So we have so what we've done is we've built a set of Terraform scripts to basically stand up a Kubernetes cluster on a per pop-up TRE. And once it's done that, it runs Ansible. Once it's Ansible, it runs Kubernetes. Once you've got Kubernetes, you've got CI/CD to deploy the entire TRE in a known state. And because you've got CI/CD, any tampering or deviation in that will reset it, but also report that the fact that something is awry here. What we haven't covered here, because I've got time, is that if TREs get disconnected, the pop-up TRE will pop down, because actually we have to have continuous monitoring from all of the host TREs, and we must have continual observability about what's going on. Otherwise, how can we let someone in another TRE effectively access our data under our governance model? So version 0.1 has been stood up, proof of concept, and we're on schedule to achieve this by the end of the project. Governance, we thought this was going to be a governance project. We thought this was going to be a governance nightmare and a bit of IT thrown on the side. It's turned out to be an IT project because the governance people have rolled over and we get to tickle their bellies. Because what we're doing is we're not deviating from the well-established model. We've not fighting the governance models. If that's your governance model, fantastic. If that's yours, fine. We'll work to your governance model. We won't make you change your governance model. Why this approach? Well, I mean, we're saying that actually when we got a common data model, which is the one on the left, this stuff's easy. But when you've got different data sets and different things, you can do still federation by sending the queries out, but actually you're doing it individually bespoke, whereas we can combine the data together in real time. And the last one, where you have to join across TREs, that's currently out of scope for the other projects. So I should say there's another project being talked about in the other room right now called TRE-FX, which we're also part of. It's the bottom one and we're the top one. And I think they're complementary in many respects. We believe that there isn't one way, and I think these two major ways of doing it will show what will work and what won't work. So it's possible that, you know, pop-up TRE would allow access to a synthetic version of the data. So you define all your queries, you understand the data, you have a little bit of rummage around, and then you issue a federated query by sending the algorithms out, if you like, against the real data. That's one way of doing it. Or the other way is actually we could create entire communities here of joined up, on the right-hand side, of joined up TREs that act as a single endpoint for a more traditional idea about what federation is. That's all I got.
Hi, everyone. I'm Katherine O'Sullivan. I am here today from the University of Aberdeen and NHS Grampian, and we run the Grampian Data Safe Haven. I'm also here on behalf of the Scottish Safe Haven Network. And what I wanted to talk to you today about is how do you solve a problem like data sharing? So we are coming together as a federation to try and actually overcome the real acute challenges that we have with data sharing between ourselves as a federation. So the problem that we face, and I think many of you will face, is that each project that comes to us across our federation has specific data sharing requirements where data needs to be transferred between the different safe havens. There's complexities between the data controllers. So all of us as safe havens are data processors on behalf of our NHS health boards, who are the data controllers. And the data controllers have very different risk appetites about how data is shared, transfer methods, what's permissible, what is not permissible. They also have different risk appetites to the structure and infrastructure of each of our organizations. So some of us are on-prem, some of us are moving to cloud-based. How do you convince a data controller who is fundamentally opposed to a cloud-based approach to infrastructure because they fundamentally believe that it is insecure? How do you convince them that actually it's okay for us to transfer the data across to one of our federated partners? So we have, this isn't necessarily the best solution, but I think that we've come together as a group to really kind of work on a solution that works for us. And I think that it is something that other organizations who have to transfer data between them can also kind of think about and potentially model on. So one of the kind of main things that we are focused on is identifying common data sharing scenarios. So myself and my information governance team looked at our 10 years of data sharing between the different federations and the different health boards. We identified kind of 6 key common data sharing scenarios where we've had sort of repeated requests from researchers, requests from our health boards, and where we've had to transfer data. We've then gone out to the other safe havens and said, are there any other data sharing scenarios that you all have experienced that aren't covered in these 6 scenarios, but that actually you've had repeated requests for as well? What we then are moving on to is documenting all of our data sharing processes and workflows for those common data sharing scenarios. What we're trying to do is sort of work through all of the workflows, all of the requirements that IG and our data controllers have placed on us to actually get that data transferred between the different safe havens. And then we will work to harmonize each of those variations in workflows and data movement into a single workflow for each scenario that meets all of our IG requirements. So what we're effectively doing is going back to our health boards and saying, here's where we had to share data, and here's what we want this workflow to look like. We also will then, we're working through the process of demonstrating equivalent information security so that our infrastructure variations, et cetera, still all work to common standards and have that kind of critical information security at the core. We are doing all of this kind of documentation and all of this kind of evidence-based gathering so that we can increase trust between the health boards and the corresponding trusted research environments. Our final goal is to create a generic data sharing agreement covering most types of data sharing scenarios. So what we think right now is that we've covered about 90 to 95% of our projects. We will then have that generic data sharing agreement in place, so we don't actually have to create data sharing agreements or DPIAs, et cetera, as long as they correspond to a workflow. And then we'll see that document as a kind of living proof. So if we have new types of data sharing scenarios that come up, we do exactly the same process, and we can revise our generic data sharing agreement. So just wanted to thank all of our partners across the different health boards in Scotland, Public Health Scotland, the universities that we work with, and Research Data Scotland, who've actually been really great in helping to fund some of this work that we've been doing. So thank you very much. Amazing.
Very good. So, thank you. My name is Pete Barnsley. I work at the Crick Institute. It's a large biomedical research institute with 120 sort of groups. We think that TREs really are projects. We need to keep the word TRE to be synonymous with a project. We think we should be bringing the data to the TRE and the project, not the project to the data. So because TREs are there primarily to support research collaboration, and because researchers are involved in a process from hypothesis to results, and because the TREs are there to help support a facility to create better, harder research projects, quicker to results, and cheaper or value for money, so more can be done with the limited resources. And because projects have their own ethical, legal, and financial governances already, that's the logical structure to make everything around. And that the data only really exists for the purposes of research within the context of the project. This is a way of describing the different domains of data in where we roughly are now. If you think we've got an administrative domain, the area that creates the data for its prime purpose, you then have these fabulous, what we have referred to as SDEs, which have aggregated that data to make it available. And those researchers sitting in the research discovery domain have also got their own data from their own experiments, their own labs, their own studies. And they connect to these great data sets. But we've done that through making TREs on the edge of those data sets. And those TREs allow those researchers in through the internet or wherever. And this sort of position is where we think we are now. We think that there's an idea to say, well, how can we make a common piece of infrastructure that adds another trusted research domain of data, where the project gets created, one per project, which has a place to collaborate, but all the areas have their own spaces, their own what we call bedrooms connected to the living room in this area. And that therefore you've got security of access because it's still your bedroom, no one else goes in. We use that common infrastructure to connect the SDEs on the left with the project TREs on the right. And if we can think about using that share technology as an architectural construct within the way we architect and design our systems, then we can extend that domain of control across from the left to the right so that the actual boundary sits within the project. And therefore that information governance process is put nearer to the specific project because it itself has all the ethical, legal, and financial governances in existence already. So the areas we could collaborate on, we would like to separate TREs from SDEs in language, both in terms of funding, focus, features, and facilities. We want to make sure that we've got a common identity management. So that's not Pete, because I have two affiliations. I may be in many projects and I have different roles in those projects. So it needs to be at that level. We also want a common research project registration so that all projects are understood in the context of UK research so that they're all already, if you like, recorded and registered as being proper. This common infrastructure would be great to work on. What does that look like? And in particular, we're very keen on this concept of an architectural share. How can you make the data visible but not accessible, copyable? And then the last point is we'd like to collaborate on something which we think is missing, which is there's a big voice of the citizen. They, after all, pay for all of this through the research money they give taxes, and they're also the actual fundamental owner of the actual unique data, the microdata themselves. So where is their agency? How can we make sure that that common infrastructure has the agency of the citizen embedded from day one and not added on later date? Because I think it's going to be biting us in the bottom if we're not careful. So this is a quick conclusion. We want, we think project TREs and data SDEs make a beautiful pairing. We wish to the infrastructure projects. We have a platform that provides a piece of infrastructure for all projects by default. Those are connected in as a peer level to all of the SDEs. The share technology is something we really look at. Take, for example, the Snowflake technology that is embedded as a fundamental principle, and that audit and access of tools bring us all together. So those 2 white papers, and off we go. One of those, and one of those.
Thank you. Okay, great. Hi there. So there are a few talks today about disclosure control. I've tried to make mine quite focused. I'm Susan Krueger from University of Dundee's Health Informatics Centre. So what is disclosure control? Actually, I'll stand here. What is disclosure control? So really, it's any control that you use to manage the risk of an individual being identified through disclosure of their personal data. What new disclosure risks does machine learning pose? All trained models could have training data encoded in them, either by design, by accident, or by intent. What controls could be applied to mitigate the risk? There are a range of legal, procedural, and technical controls that have come out of their UK sprints, like grey matter and SATRE now. Also through our own just lived experience, we come up with our control strategies. So if we think about the end-to-end process, for instance, very early on, we can give a heads up around our expectations and requirements and the obligations on the researcher when it comes time at the end for them to export a trained model. When we're doing our feasibility studies up front, we factor in a percentage of holdout data that we could use later on to test for overfitting, for instance. At the point of quoting, we include a couple of extra days if we expect to be checking trained models at the end, because they do take longer, they're more complex. We work with our data controllers, so we like to raise their awareness around the risks of machine learning so they're better equipped to ask the right questions when the requests for access to data come in. Data itself, obviously, the usual minimization and de-identification practices. We'd like to monitor what happens inside the data to the TRE. So how is the data subset? What transformations are applied to it? And which subsets are used to train which algorithms? We could inform algorithm choice and pre-processing of the data. And finally, when it's time to extract a trained model, we can check for vulnerabilities and overfitting with that holdout data set from upstream. So specifically, this is my challenge to this room, is about monitoring what happens to data inside the TRE. So if we think about algorithms or trained models as either model-based or instance-based learners, linear regression is a great example of a model-based learner. In this case, it's the equation for a straight line where no matter how many data points you add, you're really the number of parameters don't change. So you're learning M and C, whereas K nearest neighbor, for instance, is a great example of an instance-based learner where a new data point, for instance, this yellow one, its value is estimated in terms of its proximity to all of the other points in the data set. So for the model to work, it has to include all of the training data in it. Support vector machine is an example also of an instance-based learner, but it only encodes a subset of data, namely the divisions between types within the data set. Decision trees can also encode data here, for instance, predicting whether a person can wear contact lenses. Training data can be encoded in the model here. These tier production rates show that people with this tier production rate on the left can't wear contact lenses, but for people on the right, we need a bit more information. Here you can see that it results in a lot of redundancy in the model. Models can be optimized to maintain their level of performance through feature re-engineering and feature transformation and generalization, basically. But still, if it's too specific, it is still possible to derive a feature set from a model if it's too small and specific. Finally, neural networks are model-based in that the number of layers and nodes is fixed up front, but the challenge with neural networks is that they auto-encode the feature set. So it's really hard to know even how the features are represented inside a model. So the key message here is instance-based models must encode some level of the training data. All models can have training data encoded in them. The simple models we're able to have a look at, interpret, understand. The more complex ones, we need special skills and techniques. So my challenge, again, what technical controls can be used to keep track of data copies and what's happening to them inside a TRE? Thank you.
Hi, I'm Emma Squires. I'm the Programme Manager for Dementias Platform UK, and I'm going to quickly go over what Deep UK has been doing to support neuroimaging research within a trusted research environment. So Dementias Platform UK is a multimodal cohort study data TRE, and this data has been brought together to enable research into the prevention, diagnosis and treatment of dementia. There's currently 63 cohort data sets within Deep UK, and of these, 19 of those data sets, those cohorts have uploaded imaging data into Deep UK as well. And with the increase of imaging data being brought into Deep UK, we've had a big increase in the number of machine learning and AI projects that have requested access. There's currently 42 approved imaging projects ongoing inside Deep UK at this moment in time. And there's been multiple challenges with being able to enable this type of study inside the platform. The first one is that the raw imaging data is really big, so storage becomes an issue, particularly when you have pre-processing of that data and you have the analysis results as well. So actually being able to store all that data was a big issue for us. There's also the issue of being able to compute the neuroimaging analysis within our environment. It tends to need quite a lot of compute if you're doing a big trained algorithm. Also, there's lots of images that are required to be able to carry out the research. So to be able to do a good trained model, you need as many images as you can. And for cohort data sets, you're talking 2,000 maximum. To have more than that, you get a better outcome. So trying to increase the numbers that we have, and also model release, and we've heard quite a lot about this. The disclosure risks associated with the AI models are quite large, and so we've been working closely with Jim Smith's team to look at SATRE as an option there. So to address these challenges, Professor Simon Thompson, who's the head of SERP and is Associate Director for Deep UK, has led a project to implement systems inside Deep UK that will allow us to be able to address these challenges. And our research officer, Lewis Hotchkiss, has developed pipelines to bring these systems together to have a more cohesive solution. So we bring in the imaging data. It's formatted to BIDS format. We deface them for further anonymization of the data set. And we tag each image with information about that image, such as the image type, gender, things that we know about that image. And we are placing those images inside a object storage data lake that was provisioned by SERP UK for access by Deep UK. And this allows us to store the data relatively cheaply and provides a working space for those researchers to be able to carry out their analyses. An imaging provisioning system was also created to be able to find those data, look at those tags, and an administrator can use a simple UI to be able to select all MRIs for a particular disease subtype. And that filtered data can be made accessible to the researchers inside the Deep UK portal. We've also stood up a 1,500 core HPC cluster that's directly integrated into the TRE. So the data never has to leave the environment for the researchers to be able to utilize that. And we've also deployed specialized Linux imaging desktops so that specialized software can be used by the researchers. We're also very much looking at pre-processing pipelines to be able to take the raw imaging data and create image-derived phenotypes. And this will allow researchers to be able to access that data without having to have the experience in handling raw imaging data. We're also looking at synthetic data to increase those numbers. So can we create synthetic brain scans? Can we create synthetic imaging IDPs to be able to allow research to happen on those and to increase those numbers? So really the areas that we are very interested in, we're working really hard in DPUK to push forward is synthetic imaging data. So if anybody's interested or warns against it or help us out, that'd be great. Again, AI and machine learning model release is becoming more and more pertinent as time's going on, that we are able to handle these types of analyses within the environments. And also, we would love to do a project on the Federation of Neuroimaging Data. We work closely with SARA, who have been standing up all these solutions for Federation. If somebody had some images that they wanted to work on a Federation project with, that would be great. And that's me done.
Hello. Right. Okay. I think I'm the guy with 35 slides or something. I've got to talk really quickly. Where's the clicker? There. Is that it? Middle button? Right. Okay, right. I'm Seb Bacon. I'm CTO at the Bennett Institute. We make open safely. I'm not going to talk about open safely today. I'm going to talk about a really interesting little nerdy thing that I think is interesting, and hopefully I'll convince you is interesting as well. It's about magic, it's about philosophy, and it's about the culture wars. First of all, I hope we can all agree this is about testing, right? Testing matters, very, very important. Last week, we had all this flight chaos, and that affected thousands of people's lives, including people like missing hospital appointments. A very famous example of the genre was in the 80s. Therac 25 was a piece of software that mistakenly overdosed people with radiation and people died. This really matters in our area, right? So sorry about the formatting, that should be really big. The point is that obvious answers are very distracting, okay? They make us miss some of the interesting details. Here's an example of an obvious question. What is 1 add 1? You might think that's obvious. Bertrand Russell didn't think so. 1910, he spent about 300 pages proving that 1 equals 1. And he said the above proposition may be sometimes useful after he did that. Now, and exactly the same point was made during the pandemic on Twitter by somebody. They happened to also mention imperialism, which activated the culture wars. And so a science communicator tried to explain exactly why it is actually the case that 2 + 2 could equal 5. But of course, because the culture wars were activated, it ended up with this magnificent piece of rage bait about woke math. So the point is how can we be sure about anything, right? As software engineers, we've got used to testing things, and the most common way of testing things is a thing called example-based testing, right? So I'm going to give you an example of example-based testing. Let's imagine we've got a function that adds 2 numbers, x and y together, okay? Here is an example where x and y are both 2. 2 add 2 is 4. Great. So in automated testing frameworks, we run that code automatically, and if 2 add 2 equals 5, it explodes. The system gives you big warnings, usually in red, and you know you should do something. Okay, let's just simplify that because what we're doing in our head when we write the test is what is 4 is 2 add 2. So we're going to simplify that, and then we just think of more examples, as many examples as we can think of. What happens if we add zeros together? What happens if we add negative numbers and fractional numbers together? And so on. That's great, but the problem is we're marking our own homework here, right? We can't be sure that we've got all of the examples right. So what happens if you add these 2 together? Would you ever think of writing this example if you were doing example-based tests? Probably not. How did we come up with that example? Because we did. This is a true story, by the way. There's a thing called property-based testing. That's the thing I'm really excited about. And property-based testing is like getting a very overactive toddler and throwing it at your code and getting it to smush it around until by accident it finds bugs in it. So in this rather creaky metaphor, let's imagine that the playpen here is the function. That's the area we're letting the toddler play in. And then we give them a box of numbers, which is unimaginably big. It's all expressible numbers. It includes infinities and subrational numbers and all sorts of things. And it comes up with all of these examples for you, which is one of the things I think is absolutely magic. And in this true story, it found an example where that number plus that number equals the wrong answer. Now that is very hard to reason about. Like you can't really see what's wrong with that looking at it. So there's one other bit of magic I want to tell you about. In a good property-based testing system, your toddler can take the example and it can simplify it into the most simple version of the same bug. And in this case, it found the problem. The problem in our system when we were adding two numbers, 0.5 and 0.25 together, was we got 0.8, which you can start to think, oh, maybe that's about rounding, which it was. Another bit of magic. Right, I promised philosophy. That was Bertrand Russell. So how can we be, okay, 1 minute left. How can we be sure that the thing on the left and the thing on the right are the same thing? Bertrand Russell defined two in two different ways. He didn't actually prove that 1 add 1 equals 2. He just proved that the thing on the left and the thing on the right should have been the same thing. So why are we implementing addition? You might be wondering, because that's kind of a solved problem. Well, we approach the problem of phenotype definitions, so clinical variables, by writing the code once and running in different SQL databases that are different places where the data lives. So we use a thing called Urkel, and we wrote the tests, and the tests found out, because obviously if you want to make a risk score or something, that's where addition comes in, found out that the error was in SQL Server and not in this cloud database called Trino. But it's not really an error in SQL Server. Actually, it was a reasonable choice by SQL Server to implement rounding in that way. So we have to find a way of deciding what we want the actual behavior of the system to be. So we make a noddy database and we run all of our tests against the noddy database, which is a very, very simple database that's very easy to think about. And that's it. I did finish. That was the last slide. Testing matters.
Okay, hi everybody. So I'm Harry Hamilton-Jennings, a solicitor from VWV. We're a UK law firm with 5 sites and a strategic focus on life sciences and also higher education. I only actually have one slide, and now I feel silly because that multiple slides was great. Anyway, so I'm going to talk about commercializing the output of research projects involving TRE data. And this is really the sort of user perspective, but it might also be useful for those managing users. The government's tagline is data saves lives, and I really think some of these TRE projects are going to achieve that objective. But it's all about innovation, and somebody owns innovation, and the innovations that come out of these projects could be the foundation of some very exciting new businesses. So it's important to know the steps from I would call it the data bench to the patient's bedside. So I'm going to give you some of those steps, but just for context, we're talking about taking TRE data and changing it, sorting it, adding to it, mixing it with other data sets, and ultimately analyzing it in a way that comes up with new findings. Think things like data that points towards a new biochemical target for a medicine. Step 1, know your TRE. So TRE refers to a particular organization or group of organizations. And it might be that there's an intermediary between lots of data controllers. So know who your TRE is and who exactly is giving you the data. And get your hands on their terms as soon as possible so you can start reviewing it. And you want to be looking at intellectual property terms, things like the ownership of foreground IP, grants back of rights to TREs, obligations to publish, and of course, payment. Next step, make sure that your output is protected. And by that, I'm mostly talking about making sure confidentiality agreements are in place, covering every individual that you're working with on the project. But don't stop there. Take it one step further and make sure you have the systems and processes and attitude to make sure the output remains secret, essentially. Next step, consider what other agreements are relevant. And there we're talking about third parties that have some kind of interest in the project. So in terms of documents, you might be thinking IP policies of universities, collaboration agreements, consortium agreements, funding agreements, and also if there's any sort of licensed technology, then the terms of the license. Next step, consider, based on your analysis of all those things, what is the best strategy to maximize what you know you will own and are free to commercialize. And that might go one step further and focusing in particular on things that could get you a patent or are known to be successfully protected through trade secrets. And finally, I know it's boring, but make sure you have very good records of what anybody has done in your research project, what data you've got, what's happened to it, etc. Because if it's an exciting output in any way, that kind of thing will come under very close scrutiny. So I'll just finish with use your IPs, open doors, and start discussions. Thank you.
We need a little bit of a tech rejig now. Oh, you still had a minute if you want to go through your get into touch slides. Stay there for a second. Okay, Oriol, you here? All right, so we're going to have a demo. Am I saying Oriol correctly? Oriol? Cool. We are going to have a demo. Oriol, I think what I'm going to do. You share your screen now. I think you should be fine. Right?
Thanks. Okay, hello. I have been working at the University of Edinburgh for 10 years trying to solve the problems on how to reach large genetic data sets and how to access and query data from the point of a data custodian, but also from the point of view of a researcher. We performed several attempts to do that. We found different problems, and we ended up creating a platform that we believe that can solve many of these problems. And we ended up creating a spin-out. We're in conversations with different data cohorts, and I would like to show you a demo. So some of the features is that the data is always protected. The researcher can never see the data, even through a platform that keeps data secure, and that provides lots of advantages, like you can have full accountability of what happens with the data. You can reproduce exactly what a researcher did, and others can collaborate and build on top of that. You can build mods where you charge researchers very small amounts for a small analysis on the data instead of having to give the data away and give a big fee to access data and things like that. So I'm just going, because there is not a lot of time, I thought that perhaps I can just show how a researcher can perform analysis using the platform. So let's say that the researcher has been granted access to query 2 cohorts. These 2 cohorts are of the size of UK Biobank, so the platform is also extremely performant. And let's say the researcher wants to run a GWAS on one of these cohorts. So it can select the cohort, select the type of analysis that it wants to run, and then say, okay, this cohort has ICD-10 codes, and I want to select the individuals that have this code as cases, and then I want to correct by smoking. Let's say that I move here smoking. Smoking here in that cohort is a categorical variable where the individuals that have these categories. Perhaps I want to say, okay, my previous and current smokers, I want to put them on the same category. I can do that. And let's say that I am happy and I can run an analysis on here. So what's happening here is that this web tool builds the specifications of the analysis, how data has to be transformed. It sends that to a server. That server holds the job, and then the computation engine that it can be in premises, in cloud, wherever the data sits, picks that job, prepares the data, runs the analysis, and sends back the result. And this is a real-time GWAS on UK biobank data sizes, so 500,000 individuals on a single server, 10 million variants. So from here, then you can extend your analysis, and you, let's say you want to just explore the results using a Manhattan plot, or you want to combine with other databases, or you can build further analysis on top of that. Now, let's say that I want to run the same analysis on another cohort where I have a project approved, and I can follow the same processes. I put here my dashboard, a widget that represents the cohort, and I'm going to run the same analysis. So I'm going to use, I see the codes again. And I'm going to select the cases. And I'm going to correct for another variable now. Okay. Okay, now it's happening the same, but this cohort may be in a completely different place. So one can be in Australia, the other in China. The analysis is running. And I have here, as before, 1 minute, yeah, the result. And now let's say that I want to just combine the results of both. I can drag that to here and say, okay, I want to compute a meta-analysis with this from these two cohorts. And here I will have the results from the combination of the results from these two cohorts. And the system is very modular. You can extend from different data sources, extract from different places, different models, different types of analysis, and we can create a set of microservices that work together to expand the type of analysis that you can do, and then develop a widget that links with those so that you can expand and construct further analysis. And yeah, I'm going to finish here. Thank you.
And last but not least, this room. Feel free to just like put the stuff down. PDF. So do you know how to get in presenter mode? Interesting. Let's see, do that. Does anybody know how to present in PDF? Great opportunity for collaboration. View and then collaboration in action. Where's the? Here is that. Okay. Okay. It's not yet. It's not yet.
Hello. Hello. Okay, so. It's fine for everyone. Okay. Hi, everyone. I'm Raymond Hunon, and I lead Life Science and Research Department here at Google Cloud. And I'm going to talk to you about a trusted research environment for life science, which means basically for research setting, NHS pharma, and including also academia. I think, is this one? Yeah. So when we start really looking at building a trusted research environment, we took 5 key points that we need to tackle. And those 5 key points were highlighted clearly by HDI UK. And for the first one is data. So when we talk about data, we are not talking about structured data only. We are talking about structured data, unstructured data, same thing that's coming from wearable and so on, text form, GP notes, and also imaging data, which is quite interesting because it gives you the full spectrum of a patient. Now, when you have all of this data, you need to have a common place where you can put them. So that's where our cloud platform comes in. So you can put it and then you can create project.
Why the idea of project is very important is about security, because there are certain people you don't want them to have access to certain data. There are certain people who should have access to specific data. Certain people have access to synthetic data. So we manage that underneath and we automate that process. What does that mean? You don't actually need to worry about that yourself. We will do it for you, and we provide audit and monitoring that you can actually track it yourself. Then third, the people. Obviously, we have multiple people who want to access trusted research environment. Based on who they are, you need to assign security. I'm having this conversation which is very security focused, but it doesn't mean it cannot go on to things like AI, data scientists. And then safe setting. You can create some secure environment for specific purposes. And also, I have heard earlier someone talking about how do we manage the compute. Those secure environment can be specific projects that you can put some specific guidelines and policy so that they can run for a certain type of budget that you have, or when they are run and it's finished, it can just go die. For example, it can turn itself off. And then the output. We can also monitor the output, make sure that based on your IG requirement, based on what security framework you have in place, this is what is being provided. Yeah. So by doing that, we need to kind of make sure that we are compliant with the CISO requirement around data security. And one of the way we do it, we have you can create workstation where people can access it via the internet, or it doesn't need to be collected via the internet, so that you don't need to worry about security issue, because we have certain technology in our own cloud network where it allows you to actually share data without it never accessing the internet. So who this really matters to, you have data owner, controllers. I think we all know this kind of piece. We all know this kind of profile of people. So the key thing is, based on who they are, you can tell us, based on your policy, which kind of right policy it needs to be applied, and which kind of access level, which kind of visibility of that data they need to have. So how do we do that? I'm not going to talk about all of the technology, but we can discuss it a little bit in more detail when you're interested. But the key point is I want to mention is Cloud IAM. The way we do security to enable that granularity of data access is from the browser, we start protecting your environment. And not only just from the laptop, from the browser or from the application, from the browsers that you use. And we use Cloud IAM for it. The way we do, we share data without having access to internet is something called VPC service control. Oh, I need to go fast. So this is one example of perimeter control, but definitely we can talk in more detail about those different aspects. So you can see we will identify from the browser of if this computer is unauthorized or not authorized. If it's not authorized, it will block you automatically. You'll never go anywhere. If it's authorized, it's go through different process and different security mechanism up to the point where you go to the authorized bucket. Same thing, we mitigate exfiltration. What does that mean? You cannot take data out unless it has been approved and follow certain specific process. We have about private access and hybrid. We understand that you can be on-prem, you can be in the cloud. So we have technology to enable those two to work for you. One thing which is context aware is we look at also how you have been using this data and which manner. If someone start using data in a way that it's not approved, 5 minutes. We just stop you. That's just the last one.
Sorry, it's such a horrible job. The good thing is, though, that we are going into lunch now.